Okay, good morning, Level 3 students. I just want to give you a bit more of an insight into some of the material that I've uploaded in terms of validity, reliability, accuracy and precision. I mean, a lot of this stuff can be found online or on the textbooks, but just so that you've got a bit more of a clearer understanding, I'm just going to very briefly just go through them just so you can understand. So in terms of face validity, I've got a load of different visuals here in terms of newspaper headlines, breakfast companies, as well as Lucozade Sport, which a lot of you are probably more familiar with. And with face validity, this is really just in black and white terms, how true is the statement, or how much sort of truth is there to the so-called study or claims. So a really good example is obviously with Lucozade, 33% more endurance or better performance compared to water. So in terms of its face validity, that is something that you'd probably question, because when you actually look at the research, it wasn't very robust. It can easily be pulled apart and critiqued. So I wouldn't really say that the face validity of Lucozade Sport holds up, and neither do the ones with breakfast companies. So face validity is more about what does it say on the front cover, and can you really take this as factual or not, yes or no. Okay, with these three terms here, internal, external and ecological, we'll start here with the internal validity. With internal validity, this is, in a nutshell, anything that can potentially change the results, whether it's more positive or negative. So with a visual illustration here of inside out, maybe this is to do with your own personality. So if you are feeling positive and happy, you might perform better. If you are feeling really agitated, you're angry, you might perform, perhaps better or worse. You might feel a bit more resentful towards other people, especially in our studies when we did the control group as well as the testing group. Maybe the control group might try to go out to prove a point, and they might be more motivated to take part in the study and do better, just to kind of throw the results off because they didn't want to be in the control group. Again, you might be fairly depressed or sad or upset. It might change your results, but this isn't necessarily about internal, internal emotions. This is also to do with anything external as well, because internal validity purely means that it's something that could be changing the outcome of the results. So even things like here, weather can play a massive part, because if it's sunny, you might perform better. If it's raining, cloudy, windy, snowy, if you're getting cold, you might not perform as well. The surface area, the shoes that you wear. So you really need to make sure that for internal validity, it is anything that can change the results. With external validity, we're really talking about who the population groups are. So these two images here, male and female, or America and Great Britain, we're basically saying that if the study is looking at, say, the effects of how squats improved sprint times with college rugby players, the external validity is about who was used and who was selected for that study. Because if you're going to use a load of BTEC students, we've got netball, football, basketball, track and field, and we've got loads of different types of athletes in our classroom. So the external validity would not be very strong, because we're not rugby players. So we need to make sure that if you are creating a study and you want to test football performance or netball performance, and like what we did, we looked at netball accuracy, free throw accuracy in netball, you need to use netball players. Because technically speaking, our study was not externally valid, because we had a load of footballers, rugby players and basketball players, as well as non-sporties taking part in that study. So you need to make sure that any study you take part in, the external validity is making sure that the population group is appropriate. So if you're testing footballers, or you're testing football performance, you need to use footballers. If you are looking at elite level football performance, you need to use elite level footballers. If you're looking at males, you need to make sure that you're using males, or so on and so on. And finally, the ecological validity is more about the environment in which the study's taken place. So if we're looking at improving football performance, we need to make sure that everything is associated to the football pitches or the fields. Because if we're doing field and lab-based testing and we're inside a sports hall, for example, or if we're in a lab doing any type of VO2 max testing, the ecological validity is not going to be very strong because we're not replicating the same environments that the sport is taking place in. So again, all these things, they can be quite difficult to manage and get them right in a study, but that's the point of validity. You need to make sure that all three of these are robust enough to get a really good research design. With the next slide here on reliability, we'll start with this one here, into research reliability. And what I've got is on the left hand side, there's three different photos here that represent exactly the same test, which is the hand grip dynamometer test. So with inter-research reliability, this is just trying to make sure that although the test is exactly the same, here's three different methods that a researcher might do differently. So if I was to give you a hand grip dynamometer test in class, I would have been assessing how each student conducts that test. And some of you will just sit on the chair and squeeze it. Some of you would stand up. Some of you would hold it above your head and then come down in 180 degrees down to your side. So there's loads of different ways that you can take part in this test, and you don't really need any directions. I could just say to you, right, we're going to do the hand grip test, off you go. And there's a lot of different ways that you could do it. So in terms of inter-research reliability, it's making sure that the actual researcher themselves is conducting a robust approach where everything is exactly the same and is identical. Okay, so that results can't be slightly different from what they were before. With retest reliability, this is just to make sure that results are consistent. So that if you were to do this study somewhere else or on a different day, you should really be producing exactly the same results. One way that I like to use this as an analogy is, imagine that you are taking part in this test in parallel universes with 5 different researchers, and technically speaking, if you're all taking part in that study at exactly the same time, you should all get exactly the same results. So with things like here, we've got a stand and broad jump. Some people might just stand here, but then they'll just look down at the result and go, oh, you jumped 2 meters and 40. Well, have you really used the tape measure from, hill or from toe to hill? When you're doing sprints, you're using timing gates or using a stopwatch. And again, doing the standing vertical jump, are you fully stretched out before you do your final jump? So it's just making sure that whatever that result is that you got first time round, you are likely to be getting exactly the same score. So again, hence the name test and retest reliability. So in a nutshell, reliability is making sure we get consistent results. Okay, and then finally for the last slide here on accuracy and precision, as a visual representation here, you've got 4 different photographs that show the differences between precision and accuracy. So in terms of precision, this relates somewhat to reliability, where the results here have been consistent. You've always got the same result time and time again, but they were not necessarily accurate. And again, this one here, the accuracy is somewhat in the middle, so the results are fairly close to what they should be, but again, they're not quite precise, they're not quite in the bullseye, and again, you get the idea here and here. So how do we put these into examples? A really good way is that, imagine if you were doing a 1 rep max bench press or a 1 rep max squat. And in, for example, our college gym, the weights go up in 5 kilos or 5 or 10 kilos. So if you were lifting 100 kilograms on your back, and then you went to jump up to 110, maybe that is the most that you could lift. You're not going to be able to jump to 120 kilograms. So if we were to give you 10 minutes of rest and try again, you'd probably get that same result. So that could be a good example here, where that 110 kilo squat was very precise. He was always hitting exactly the same score. However, was the result accurate? So was 110 kilograms your true 1 rep max? And the answer is probably not, because you could have lifted 111, 112, 113, 14. You could have lifted maybe a little bit more weight. But again, we can't know that for sure because the weights jump up at quite a degree. We've also got, if we go back to the other slide, these things here when you're doing sprints. So if you're doing hand time and you're doing electronic timing gates, the electronic timing gates are always going to give you very, very accurate times. Very accurate times. But then again, with the hand time, you might get inaccurate results, and also they might not be precise. It depends on when this person is going to start the watch. So we need to make sure that whatever test that you do, if you are sprinting 30 meters and you run 4.5 seconds, did you actually run 4.5 seconds? Or did you actually run 4.3, 4.2? Did you actually run 5 seconds? And that's where we need to find out whether that result was accurate or not. The precision is more about if I have 5 goes at it and I always get 4.5, 4.5 and 4.5, well that was a fairly precise test. But the accuracy is to be questioned because maybe we wasn't using electronic timing gates. So, I mean, feel free to use the timing gate analogy as an example, or even use the 1 rep max as an example. But this is really what we're trying to go for. So if you're thinking of a study, can you think of a study that is precise and is accurate every single time? And I suppose the only way to really truly get that type of result is maybe through things like flying sprints, where you sprint, let's say 40 meters, but you start 10 meters back from the timing gate. So that your first 10 meters you're sprinting in, as soon as you hit the beam, your time is being recorded until you get to the last beam at 30 meters. At least that way you know that every single one of those runs is electronic, so it's always going to be accurate because that's your true sprint time. And it will always be precise, because if you are sprinting absolutely flat out for 40 meters, you should always get that exact same result, give or take maybe a tenth or so.